Thank you all for standing by, and welcome to today's webinar, Running Private Terraform Enterprise on Azure. Please feel free to type your questions during the webinar. This webinar is being recorded. The recordings will be made available after post-processing, usually within 1 to 2 days. Today, our speakers are going to be Nick Jackson, Developer Advocate from HashiCorp, and Zachary Deptawa, Cloud Developer Advocate from Microsoft. And now, we'll go ahead and get started. Go ahead, Zach.
All right, everybody. Happy Tuesday. Thank you for joining us today on this webinar. So what are we going to be covering? We're going to be covering today the Microsoft Azure and HashiCorp Terraform partnership at a very high level. We'll also discuss Terraform with Azure to enable repeatable, consistent deployments, and we'll cover what Private Terraform Enterprise is, how it's used, and then we'll finish up with a live demo. So I know some of you may already be familiar with HashiCorp, but let's go over some basic history of the company really quick just to get started. So HashiCorp was founded in 2012 by Mitchell Hashimoto and Armin Dadgar. So they both saw a shift happening in the world of operations engineering from more of a dedicated approach to using a cloud infrastructure. And as they navigated the space themselves, what they found was quite a large gap in tooling for provisioning, securing, and running new infrastructure in the cloud. Each cloud provider seemed to have their own way of doing things, their own APIs, their own even naming for certain types of services. So going from one provider to another was a really painful process. That meant retooling, or that meant changing processes completely to fit the requirements of new infrastructure providers. So this often left companies and developers locked into a particular environment, or that meant if you had several different environments, you had different processes to manage those environments, which was really painful. So Mitchell and Armin, what they realized was how you are required to provision traditional infrastructure is very similar to cloud infrastructure. So they set out to make a tool to fill that gap that would help you work with the challenges of distributed cloud topologies without having to retool or having different processes. So that's when they built HashiCorp to build a product suite that would fill that gap for operations professionals to help provision, secure, and run hybrid cloud infrastructure without being tied to any platform or technology. And so HashiCorp is primarily known by its key product names. So you may or may not know these products actually are HashiCorp products, but they are. You can see the key products here: Terraform, Vault, Console, Nomad, Vagrant, and Packer. And these are really common products in the DevOps world and the infrastructure management world in general. So it's very possible that these products, or at least some of these products, are being used in your organization today. So now let's talk for a second about Microsoft's cloud computing services platform called Azure. So this was first released 8 years ago in February of 2010, excuse me, and it's gone through some changes. But really, how does it differentiate itself from other cloud hosting providers today? So there are really 4 pillars that represent the main value proposition for Azure. So we focus on providing unparalleled productivity. We offer integrated tooling from mobile DevOps to AI, machine learning, serverless computing, everything in between. There's over 100 services that support the latest open source technologies, and you can use any dev tool or language to easily monetize applications to your heart's content, really. Our platform helps accelerate application delivery using agile development practices like continuous integration, continuous delivery. And we love open source technology. We're built by developers for developers, so we just can't get enough of open source technology. We're a very big open source contributor. We care about real hybrid consistency and flexibility. So what that means is you can do things like have an Azure cloud environment and then deploy an Azure Stack environment or Azure Stack servers inside your own on-premise data center for data sovereignty reasons and enterprise application reasons, where you want those servers locally to you, and you can have the same experience from cloud to those on-prem Azure Stack servers. You can also do things like deploy Azure Active Directory for a single sign-on experience between Azure and other environments completely. We also help create the next generation of intelligent apps using powerful data and artificial intelligence services. So you can build and deploy custom AI models at scale. You can develop breakthrough applications with built-in intelligence by using our comprehensive set of services. You don't have to reinvent the wheel here. We already have those services available, which is really cool. And we've earned the trust of countless startups, governments, and a very large number of Fortune 500 companies who all run on the Microsoft cloud today. We meet a lot of stringent requirements such as HIPAA, FedRAMP, SOC 1, SOC 2. Yeah, so these are really just some of the main reasons why customers continue to choose Microsoft Azure every single day. So I know I mentioned briefly that Microsoft really cares about open source, but it's absolutely true. It's kind of the lifeblood of what we do. So I want to quickly mention Visual Studio Code. If you haven't heard of this, definitely check it out. It's a super lightweight, totally free, open source code editor that runs everywhere. And you can download tools and extensions that make your life easier. Like this screenshot here is of the Terraform extension that helps with syntax highlighting, formatting, lint checking, validation, things of that nature. And there's also this really cool feature called VS Code Live Share. And what that allows you to do is share your current session with other people, so they can come in and edit code, they can highlight code for you. It's an actual live collaboration via that VS Live Code section. And we're actually going to demo that just a little bit here towards the end of this webinar. This is a really awesome tool for writing code, so I really recommend you check it out if you already haven't. So our engineering team at Microsoft, we've been partnered with and working closely with the engineering team at HashiCorp over the past several months to deepen Terraform support for Azure compute and networking resources. So we now have a significant amount of customers that are running Terraform with Azure. And based on feedback from those customers, the team is currently focused on sophisticated networking resources, higher level Azure services, and tooling for authoring and testing Terraform modules and templates. And we take all customer feedback really seriously, and we actually use that feedback to prioritize the backlog. So feel free to send any feedback and questions directly to me at zdeptawa on Twitter. And you can also keep up with new feature support by bookmarking our provider repository, which you can find at the short link aka.ms/tf repo. You can find some Azure RM provider documentation on terraform.io. The short link for that, aka.ms/terraform. And we actually have a Terraform hub on our docs.microsoft.com site. You can find that at aka.ms/tf hub. So these are all really cool places, really good things to bookmark for later. And so this is a screenshot really quickly of the Terraform module registry, which you can find at registry.terraform.io. This just gives you an idea of what it looks like via the website. And these are just some modules that are available for use with Azure and Terraform for deploying things like databases. You can see there Kubernetes clusters, load balancers, console, Nomad. Back in December of 2017, there were 17 modules available for Azure, and today there are 31 modules available on the Terraform module registry for use with Azure. And so these modules are actively being built. They're actively being managed and maintained. So keep an eye out here for new modules. And really quickly, what a module is in Terraform is it's a reusable bit of code. So you can think of it like a function in an application. Instead of going and writing your own code against the provider to build a database on Azure, there's already a module that can do that for you. So you give it inputs, it has outputs. It's very reusable, and it makes things a lot more pluggable and easier to get started, really. So we'll switch gears a little bit and jump into some of the challenges that surround cloud operations. So when an operations team has to deploy and manage an application, what they're really dealing with is a few things. So they're dealing with the management of the infrastructure, they're dealing with the security of the infrastructure and the application, and they're dealing with the development and improvement of that application and infrastructure. So when you think about what that means for an application to be redundant, fault tolerant, decoupled, highly scalable, what you're talking about is a multi-component application that spans data and a runtime layer. So what this means is the infrastructure is almost certainly heterogeneous, spanning several VMs or containers or even physical gear and racks. So what the operations team is often burdened with is it's not only the provisioning of that infrastructure, but with making sure that the environment is consistent, that it's secure at both infrastructure and application level. So what this means is really you need to make sure that it's deployed atop an infrastructure in a repeatable, secure, testable, consistent manner. as well as register that infrastructure with monitoring services to make sure that you're ensuring uptime. So there's several things that come into play here. And so really this is an end-to-end software supply chain. And these principles really haven't changed for quite a while. It's just as any factory, if they're building a new version of a product or its components, they would have to retool their supply chain to support the evolution of that product. And this is the same way the software supply chain is as well. It requires that new tooling to support the evolution of modern application infrastructure. And so it's sometimes hybrid, it's most often highly distributed, and it's much more dynamic than what previous tool chains were designed to handle efficiently. And so speaking about that, the traditional environment, so a traditional old school dedicated server approach to infrastructure was relatively straightforward. So the infrastructure layer was composed of physical servers that were running in racks somewhere in a data center. And the runtime layer was either directly on top of those physical servers or was running in virtual machines on those servers as guests. And the typical application was often decoupled over only a few servers or virtual machines. So you might have a 3-tier app that would have a web layer, an application layer, and a database layer. And you might have redundancy with another 3 servers, web, app, and DB, in another rack that's maybe cross-connected with load balancers and things of that nature. And so what that meant, though, back in the old school traditional dedicated way was as traffic and usage increased, the approach was to actually scale up that hardware by adding more compute power, because it was such a painful process to get more rack space, to get more servers online that could take weeks at a time. So what typically happened was a very painful downtime to increase RAM, to increase CPU, to increase disk space sometimes. And so that's what would allow for more breathing room at the runtime layer. It was a very painful process. And so around this time, when all of this was happening, cloud was showing the elasticity and a sneak peek really of the scalability that it offered and the flexibility that it offered. And so businesses started exploring the use of a hybrid model, which is the elastic front end, the burstable front web, sometimes application front end, with a dedicated database layer on the back end. And so you had this elastic front, very, very beefy, dedicated back end on physical machines or hypervisors, and sometimes for data sovereignty issues or reasons as well. But there was still a bit of a struggle, right? So you had to figure out connectivity from the dedicated setup to the private cloud segment or possibly public cloud segment of that provider, or sometimes even to another provider altogether. So you had to figure out that connectivity. Automation to easily spin up the reusable bits of your code had to be figured out. And the ability to safely create and update infrastructure quickly and reliably had to be figured out. And these were painful things back in the days of traditional old school dedicated hosting. So there was still that problem of proprietary tooling as well, where your dedicated servers lived, they did not talk or speak the same language usually as the cloud or a burstable front end for that hybrid model. So there was still that frustrating process. So enter Terraform, right? So Terraform enables infrastructure as code for automation to help solve that very critical pain point. The input that Terraform takes is a Terraform configuration file, and that's composed of, or Terraform configuration files at times, and that's composed of resources that are expressed as code. So your infrastructure is being expressed as code. It has public module registry that I mentioned just a little bit ago that operators can publish modules to, you can consume modules from, and that's freely available to everyone. And modules can also be versioned, they can be pinned, and that means that you can make sure that you aren't breaking, if there's maybe a breaking change in a new version of a module, you can pin that version so you are sure that you can test before the version changes if there's any kind of automated update process on the back end. So developer or sysadmin, anyone looking to really quickly provision infrastructure can reuse configuration modules by copying just a few lines of code into a Terraform configuration file, and there's really no need to rewrite that entire block of code. And that's what's beautiful about the modules. They allow for the inputs and outputs like I described, so they can be reused by other resources and modules as well. And operators can really build a holistic configuration for their applications, or they can choose to represent their infrastructure as modules to make it easier for infrastructure components to be reused, which is super, super powerful. It's just like functions in an application. And Terraform really consists of two parts. So you've got Terraform Core, which is the engine behind the Terraform workflow that's actually doing the work. And you have the Terraform Providers, the other piece, which is the extensible component that's responsible for communicating with individual infrastructure or cloud providers. So Terraform workflow is really consistent and repeatable, and that's super important in this entire process. It's the same every time infrastructure is provisioned. So there are two primary steps. The first step being a Terraform plan, the second step being a Terraform apply. And so what happens here, the Terraform plan, the first step, Terraform will inspect your configuration code as well as the current state of your environment being worked on if the environment already exists and there's a state being tracked for that environment. And what it does is it creates a dependency graph to automatically decide resource deployment or modification sequence for resources that depend on one another, which is pretty cool. So to give a quick example, if you are trying to provision a public IP for a virtual machine, Terraform understands that that virtual machine will need to exist before you can associate that public IP with it. And that's all automatic. So that's a really cool feature as well. So Terraform plan will determine also what resources can be built in parallel without causing problems. And that's really to help optimize the provisioning step. And so the provisioning step would be that second step to Terraform apply. And this is when Terraform actually executes the changes that are set forth from the Terraform plan command per that dependency graph and per the order of operations that was determined during the plan run. And so these two steps are applied each time a Terraform run happens. So it's one workflow, two steps, any infrastructure, and that's really the power of Terraform. So now we'll quickly cover the Terraform provider model. So Terraform providers are responsible for understanding API interactions for service providers such as Azure to expose resources that can be easily consumed within a Terraform configuration. So they're doing the communication with the APIs and with the infrastructure providers in a more easy to understand way. So they're kind of abstracting that out. So Terraform providers also include external platform as a service providers such as Heroku and software as a service providers such as GitHub, which is really cool. You can interact with all of those. And providers are separate from the core engine, and that's really to accommodate the rapid pace at which providers can be added. Additionally, new resources within existing providers can be added to extend those providers as well, so as services change. And for anyone who has infrastructure in their own private data center, maybe that is not using any kind of standardized provider or API, you can actually write your own provider that will communicate with your infrastructure in that private scenario. So that's pretty cool. So you can still use Terraform once that provider is written, and it'll be the same process across your entire portfolio. So this extensible model, what it means is that over time, as new clouds and services emerge, new Terraform providers and resources would only need to be written to use for use in provisioning and managing of those new services. So the very foundation of Terraform is the open source project. And it's been paramount in fulfilling the need to create reusable configuration for infrastructure, the need to manage infrastructure at cloud at scale, and the need to use a consistent workflow over a diverse portfolio of infrastructure providers to safely and consistently provision infrastructure without the need to learn proprietary tooling for each provider. So just goes back to that single way of managing infrastructure providers, even though they're diverse providers. And so as Terraform adoption grows within a company, so usually companies will start with the open source version of Terraform to test the waters and see how well it works. And as the need grows within a company, that's when you start seeing the needs change. And as a company gets larger, they usually start dealing with governance and policy issues. And so that's when Terraform Enterprise really becomes super valuable within a support organization. And we'll touch on this as well in the demo portion. So just as I mentioned, as your team grows, you're going to maybe find yourself needing the ability to restrict certain resources to certain groups. So just as a quick example, maybe say you have an application where your developers sit closest to the West US Azure region. You want to make sure that your dev environment only provisions servers in that region, or you need to ensure production environment is located geographically closer to a primary audience somewhere else. So these are the types of policy enforcement requirements that are possible through use of a policy as code framework called Sentinel within Terraform. And policy as code via Sentinel, it can offer more security in the form of theoretical guardrails that further protect your environment from misconfiguration or deployment issues. And we'll actually touch on this as well, so you'll see this in action. And now Nick's going to talk a little bit about private Terraform Enterprise and options there. Nick?
We released Terraform Enterprise, the back end of last year. But today, what we've actually got is the release of a private Terraform Enterprise. So that gives you the capability to take our hosted SaaS solution that was available, and you can run it in your own domain. So why would you want to do that? I mean, there are a number of reasons, but besides the one that Zach mentioned just about the great workflow, the key thing about private Terraform Enterprise is that you've got 100% control over your data. So things like running in a connected environment where maybe your version control isn't accessible to the internet. Private Terraform Enterprise has no problem with that. You've got the capability of controlling the platform that Terraform Enterprise runs on. You can configure the type of the server that you've got running in Azure. You can configure all of the settings around the network. You've got that data sovereignty controlled. You own the entire environment, so you don't need to worry about any multi-tenanted or data sovereignty leaks. If you're regulated from those perspectives, again, you've got that covered. And it gives you that enterprise performance. You've got that capability that you're in control. You can manage this. Can we get the next slide, Zach, please? So Terraform Enterprise, we've got a little demo for you today. And we're going to show you a workflow, which we think is somewhat typical of the way that an organization will work. And we'll show you some of the features of Terraform Enterprise. We'll show you how private Terraform Enterprise works and just how easy it is to use. So let me quickly just show you the kind of the workflow that we're going to look at today. So we're proposing that our environment, Zach and I's company, has a theoretical 3 environments. We've got a develop environment, and the develop environment is only used by Zach and I. It's purely just for operations to test out our configuration. Staging is an environment which is shared. So QA teams are using staging. We've got some developers using staging. There's people on that who depend on it. So we've got to take a little bit more care on that. And we've got the production environment, and production is sacrosanct. We cannot break production. So with Terraform Enterprise, what we've got is the capability to control things through permissions and access control and workflow that allows us to manage those varying levels of need. So for develop, we're quite happy to just push straight out. It's only going to hurt Zach or I if we break it. With staging, we want to take a formal Git flow approach. So we want to do code reviews on our Terraform configuration, and we want to make sure that the Terraform plans are reviewed and approved before the infrastructure changes are made. And on production, we want to take a similar approach to staging, but we only want certain individuals to be able to make those production changes. So let's see how that works. So in Terraform Enterprise, we can configure a bunch of different things. So I've already got a private Terraform Enterprise running in Azure to save a little bit of time, but one of the first things that you're going to want to do is set up version control. And Terraform Enterprise allows you to connect to a number of different version control providers. You've got GitHub, GitHub Enterprise, GitLab, GitLab Community. So a combination of cloud and on-prem version control. And we're adding more and more providers to that all of the time. The settings are really, really straightforward. So for GitHub, it's just a matter of going through and configuring the GitHub OAuth in as a new application and entering those details in Terraform Enterprise. And I've got the capability of configuring teams. So I can cut my configuration setup in different ways. So at the top level, what you have is an organization. Beneath an organization, you have a team. And beneath a team, you have a user. Creating a team, incredibly simple. So I'm just going to add a test team because I've already got some set up here, but click test, created. I want to add a new user. So I'm going to add Zach. Click add user. I can see that Zach's already got two-factor authentication configured on his account. So nice one, Zach. And then you sort of get into creating the workspaces. So let's have a look at that. Creating a workspace is really, really straightforward. So I add the new workspace button, and I'm going to give it a name. So I'm just going to call this Azure Test, if I could type. And I've got the ability to choose from all of the various different version controls that I've got enabled on my private Terraform Enterprise. At present, I've just got GitHub, so I'm just going to select GitHub. And then I can choose my repository. And the repositories are automatically imported from the version control system. So our example application is the same app that we demoed the last time Zach and I were doing a Terraform webinar, which is our Go for Search application. This is a simple application running in Azure. It's using a series of nodes for our web front end and a managed Postgres database. But then you've also got more configuration options. So why is this important? So if we take a look at our version control repository, you can see that we don't have the Terraform configuration in the root. We've actually decided that we're going to put our Terraform config in a subfolder. So inside of when I'm configuring my workspace, I can also set those settings. So it's completely configurable to the way that you work as an organization. Again, I've got the ability to bind to a version control branch. So what we've decided to do is we've decided that we're going to have a dev branch, a master branch, and a staging branch. And they're going to correspond to the three different environments: our develop environment, our staging environment, and our production environment. So I'm just going to set this up with the test branch for the time being. And I'm going to save that. So that's going to get set up, and Terraform Enterprise is going to import that. While that's happening, let me show you some more of the settings for Workspace. So you've got variables. So in the same way as you can configure your Terraform configuration to use variables, either using the flags for the open source Terraform command line, or you're using your TFVAR files, or maybe you're using environment variables. Terraform Enterprise supports all of the same features. So add a Terraform variable. I can just click the edit, add my new variable, and I'm just going to call this Nick test. I add that. But what if I need to add something like an SSH private key? So I can give that a value and just assume that's a private key. But I've got this additional option. So I can choose sensitive. Now, when I choose sensitive and I add that and I save my variables, it's no longer visible. So private Terraform Enterprise is going to encrypt that data using HashiCorp Vault. And it's going to keep it safe from prying eyes whilst leaving it available to be used by the Terraform configuration. So once you save a sensitive variable, nobody can see it. Operators can't see it. Users can't see it. Not even administrators can see it. Only the workspace itself can leverage this variable. So it keeps your data, things like your API keys and your private keys, nice and safe. I've also got the ability to add environment variables. So for example, if I'm setting up an Azure provider, then I'm going to need to set certain environment variables. So things like my ARM tenant ID, which is going to be my secret value. So I'm going to mark that as sensitive. I need to set up things like my ARM subscription ID, and again to a secret value, and so on and so on. So there's 4 environment variables you need to configure as a minimum: the tenant ID, subscription ID, the client ID, and the client secret. And when we sort of talked about our flow, one of the things that we mentioned was that with our development branch, we're actually happy that if a Terraform planner works, we're just going to push that straight out. It's only Zach and I who are suffering. So I've got the capability in private Terraform Enterprise to have these 2 different things. So I've got the capability of setting something up as auto apply. So if a plan is successful, the changes will be applied automatically. And I've got the capability of a manual apply. And this is the one that you're going to most commonly use. This means you've got that 2-step approach. Somebody has to look at the plan, they have to confirm it's okay, and they have to manually action the infrastructure changes. You can set all sorts of things like the Terraform version, and if you're using a particular version of Terraform, that's all available. And I can add things like SSH keys for my version control and module sources and things. Just quickly back on the access. So I created a team before. I created the test team, and I can assign a team to a workspace. So I can assign the same team to different workspaces with different permission levels. What are those permission levels? So we've got read, and read access will basically allow you to do things like look at variables. It'll allow you to look at some of the runs, and it'll allow you to run a Terraform plan. Write access allows you to do everything as read, but you can do additional things. So you can do things like approving a plan to make an apply and execute infrastructure changes. You can do things like editing the variables, and you can do things like locking and unlocking the workspace. Administration, one more level up. So with administration permissions, what you can do is you can do things like delete the workspace. It doesn't give you administration over the private Terraform Enterprise instance, just the workspace. I can delete the workspace. I can change things like the version control settings. I can change the various settings and all sorts of additional features that you might need. So again, just adding that to read, I can add the team, and it's as simple as that. So let's have a look at our workspace. So we've got like a little workflow for you. So, hey, Zach, could you do me a favor? Could you change the Gopher Search app? Could you add us a port for TLS? So open up port 443 on the firewall, please.
Okay, that's no problem at all. Let me see here. So in our Gopher Search app, Nick, we're on VS Code Live Share. Can you point out, do you want that in the main TF file?
Yeah, one second. Let me just flip that open. So it's main TF. So basically, if we just copy this resource and we add a new one, but for port 443, that would be amazing.
Okay, that sounds good. Let me copy that real quick. So I've copied that over. Making some changes for port 443. Okay. And I'm going, oh, go ahead.
Yeah, I was gonna say, if you can push that to GitHub, then that would be amazing.
Yeah, no problem at all. Okay, I've saved that change. I'm on the dev branch here. I just staged the change. And I'm going to commit that change now.
Perfect.
And
so what's going to happen? Oh, that's amazing. So what's going to happen now is if we look at private Terraform Enterprise, we're going to see that it's going to pick up the change that's been pushed to GitHub, and it's automatically going to run a Terraform plan. So this will just take a few seconds, but you can see in the output there, the output from the plan. So this is something you would see as if you were running the standard open source in the console. You could see that it was adding one new resource. And because of the way that we've got this particular workspace configured, it's automatically going to run a Terraform apply. And you can see that's run successfully. So the next thing that we need to do is we need to merge this and push it up to staging. So Zach, mate, could you push this, create a pull request so we can get this into the staging branch, please?
Sure, Nick, that's not a problem at all. So here I am. Let's do a pull request. So I'm creating a pull request now from dev to the staging branch.
Perfect.
About adding this port 443 rule, and I've created it.
Awesome. Let me just give that a quick code review. So again, we're using the Git flow approach. Now you can use Git flow for your, not just your code, but you can use Git flow for your infrastructure code. And Terraform makes this really easy in Terraform Enterprise as well. So what I can see is on that pull request, I can see that Terraform is automatically running a plan against the configuration. So it's running a quick check that everything's valid and syntactically correct. I can go in and look at the files changed. I can see that Zach has added a resource. I can give this a quick eyeball. If I want to, I can link out to the main file. And actually, Zach, sorry, mate, I've just noticed something. So if you look at the main Azure resource, so we've got corporate policy, which dictates that we've got to have as a bare minimum an environment and an application tag. Could you just add an application tag for me, please, and push that back up?
Sure, give me just a second. So I'm adding application equals go for search here in the main TF file.
That's
I'll
perfect.
save that. I'm going to stage the change and commit it. It's been committed to dev. Do you want me to go ahead and push that?
Yes, please, mate.
Okay, I've pushed that change up.
Brilliant. So let's we can merge that through as well. So we're going to see that that workspace is going to plan. It's going to run through, it's going to build, and then we can actually action the pull request that Zach just created. So
okay,
again,
you want me to go ahead and merge it?
Yeah, we'll cut some corners just for the demo here. So we'll merge that that change. So this is now merging it into the staging branch. If we go back to Terraform Enterprise, what you're going to see in the workspace is the staging environment is going to start to run. So there we go. That's planning now. And in just a second, that's going to come back so we can see everything's looking good. We're adding one item, which is our new resource for our security rule, and we're modifying one of the resources to add those application tags. Now, one thing you'll notice different this time than what was on our develop branch is that we have to manually eyeball the plan and manually action that everything is okay before we apply it. That gives us a little bit better of a workflow, a little bit more security around being sure that everything's okay with our configuration. Zach, you're good to confirm and apply that.
Okay. Looks good to me. Confirmed and applied.
Perfect comment. And why don't you open up a pull request so we can get this merged into, get staging merged into master as well.
Okay, we'll do that. Let's do staging to master.
So fairly standard sort of workflow. We're just moving the changes through the environment, checking them as we go. And Terraform's really helping us with this. And you're all good. Just you can merge that into master, Zach.
Okay. And I've merged it.
Perfect. So exactly the same as before. What we're going to see this time is the production environment is now going to plan. So it's going to go through the step. The production environment is going to run the plan. It's going to check the changes for the configuration. It's exactly the same sort of standard Terraform stuff. All of the state for this environment is stored securely and encrypted inside of private Terraform Enterprise. I can see that there's one change to make. And if you scroll up to the top of the screen, what you can also see is that it's alerting me to say that it needs confirmation. So exactly as the same before, we've got this two-step approach, plan and apply. So now we need to apply it. However, because Zach only has read access on this particular workspace, whereas he had write on the previous ones, he doesn't have the ability to actually execute the apply. So let me just quickly do that. So if I look at my Terraform Enterprise and I've got write access on this workspace, again, I can see it needs confirmation. I can hit confirm and apply. I can use the looks good to me, universal one fits all confirmation message. Terraform is going to go away. It's going to run that apply, make all of my infrastructure changes in Azure, and we're all good to go. So we're almost through with the demo, but just before we sort of go, I want to show you another feature. So one of the things that we mentioned in this like little scenario that we were running through is that as an organization, we have tags which are mandated. So we dictate that we have these environment tags, and it has to have an environment and an application tag. So what I can do is I can use Sentinel, which is a feature of private Terraform Enterprise and Terraform Enterprise, and allows me to write policy as code. So I can validate that my Terraform plans have got the right elements with the right settings. So for example, if I could write a policy which said I'm not allowed to open port 22. Or I can write a policy like this example here, which states that I've got to have these mandatory tags. So reading it from the bottom to the top, we have a rule. And a rule is something which has to equate to true or false. It has to pass for the plan to, the apply to be allowable. So all I'm doing is automatically Sentinel is going to make the resources which are in my configuration available to me. So I can iterate over those Azure resource groups, and then I can look at each group and I can check the tags. So I look at my get tags, and this time I'm writing a function. I can use the keys keyword, which allows me to turn a map into a flat list, and then I can loop over that list, and I can check that a tag is not in tags. So what we're trying to do with Sentinel is we're trying to not make it so programmery. We want to kind of try and find that happy medium where you've got programmer flexibility, but you've got configuration which is easily readable. Zach, mate, could you remove the application tag and just, oh, sorry, 1 second. Let me just add this in Terraform Enterprise, and then we'll push that to the dev branch and see how it works. So adding the Sentinel policy, super simple, into my organization settings. Policy is applied across the entire organization. I'm going to call this Azure Resource Group Tags. I've got the capability of 3 different enforcement modes. So I've got the ability to say hard mandatory, which means that policy can't be overridden by anybody. It can't be overridden by administrators or anybody with access rights. The only way to override hard mandatory policy is to remove it. I've got soft mandatory, and soft mandatory allows me if I have the right level of permission to override certain policies. And we've got advisory, and advisory only logs that a policy would fail. So this is useful if you're introducing maybe a new policy and you don't want everything to fail immediately. You want to give the teams some time to transition. So I paste that in there. I save my policy. And Zach, if you can push to the dev branch again, and we'll see how that works as part of the execution path.
Okay, I'm removing the application tag now, and it should push up here shortly.
Excellent. So what we're going to see is we're going to see our dev branch, and we're going to see a new run. So there we go. That's triggered already. So let's have a look at the run. So again, pretty standard. We're running Terraform plan. So we've got one change to make. This time we're removing a tag. That plan's going to come back green because it's perfectly valid configuration. However, we've now got an additional step. We've got a policy check step, which is using the Sentinel policy, which I've just created. And you can see this has failed. And the reason this has failed is because the configuration that we've just pushed is out of policy. So we've got a missing tag application. If you recall back to my configuration, I had mandatory tags of environment and application. Now, again, the way that I've got this dev branch set up is that it would automatically, if I hadn't that Sentinel policy, have done an apply once the plan had succeeded. Sentinel gives me that extra layer. So it'll not allow me to apply regardless of my permission levels if the policy fails. And it's a great way to introduce this codified either security or just governance into your organization. So that's the end of our demo. We've got just 2 last slides, and then we can jump into a little bit of Q&A. So back over to you, Zach.
Awesome, thank you, Nick. All right, so where do you get started? Where should you go from here? So I would definitely recommend checking out Terraform on Azure documentation at aka.ms/tfhub, as well as documentation on the Terraform providers, which I mentioned earlier. And if you haven't already played with Terraform, I really recommend checking out Terraform open source. You can play with that for free. You can find it at terraform.io. Something else to mention too, if you don't already have an Azure account, you have, if you go create an account, you have $200 in credit to spend on any Azure products within 30 days. So it's worth checking out and playing with the services to see what you can do on Azure. And then Nick, do you want to talk about the Terraform Enterprise information?
That's right. So today, private Terraform Enterprise is generally available. So you can go to the link there and get a trial, and you can set up Terraform Enterprise just like we've been showing you in your own environment. So whether that's on your Azure cloud or whether you're running it on Azure Stack, we can do that today. And I guess we should open the floor for any questions. Yeah.
Thank you, Nick, and thank you, Zach. That was a great demo. We do have a couple questions that came in. One is about setting up backups. So can we take a backup of the infrastructure we built using Terraform as an image and then use it to restore it in other environments?
Is this specifically for Terraform Enterprise or just Terraform in general? Do you know?
I believe it's just in general talking about infrastructure that you're constructing with Terraform.
So if you define your infrastructure with Terraform as infrastructure as code, what you get is that declarative approach. So you've got the capability that you can run it against different environments. So when I was sort of showing you the example that Zach and I were working through, we were actually using exactly the same Terraform configuration, but we were deploying it to different environments. So it gives you that reproducible and that consistent approach to your infrastructure management. With private Terraform Enterprise, just in case the question was about that, you can absolutely back up all of the state and snapshot, and it'll actually automate a lot of that for you, and it'll store things into a number of sources such as Azure Cloud Storage and stuff like that.
Thank
I
you.
hope that answered.
Thank you. We also had another question. You set up a team with you and Zach, Nick, and so we had a question. Can teams or organizations be plugged in from an existing data source? So say like a corporate directory?
I don't believe so at present, but it is probably one of the things on the roadmap that we can sort of run through a little bit later on. Maybe in a different webinar where we can show how we can plumb that in from Active Directory.
Excellent, thank you. Zach, we actually had an Azure question as it relates to Terraform. So can you talk a little bit about how you configure your Azure login credentials and how long they are available for? So like, are they available for hours or days? And then talk a little bit about how Terraform actually pulls those credentials.
Sure. So the way that you set up your credentials through Azure, you can do it from the command line using the AZ CLI. Which is super easy and super powerful. There's lots of tutorials on how to do that, the exact commands you would run through. But in terms of creating those credentials, you would go through and create a tenant and a service plan, and basically every bit of credential that you need, and there's various steps you need to go through to do that. But how long the credentials last, you can actually set, if you're using tokens, for example, you can set lifetimes for those tokens. So you can set that depending on how you're using those credentials. In terms of, if you're talking in terms of how long an AZ CLI login might exist, just in case they're talking about that, I believe it is as long as you are active in that AZ CLI work, and you have not been inactive for, I believe, 14 days, it will remain active. So the way Terraform uses those, if you're using Terraform open source, you want to set those to environment variables or something that you can source outside of your Terraform configuration. And the reason for that is you don't ever want to store your sensitive data, your login information or security codes inside of your document root, especially where you're likely putting it, up into version control. So you can source that. You have those environment variables, and then Terraform will actually pull them through those environment variables. The section where Nick mentioned the sensitive variables, so that's where you would set those variables inside Terraform, private Terraform Enterprise, to pull that data. And like Nick mentioned, once you've set that to sensitive, there's no way to go in and edit it. There's no way to view it. Not even owners can view that. So the only way to change that is to wipe it out completely and replace it. So that's where those credentials are stored. And I hope that answers the question.
Thank you, Zach. We also had a question about Azure asking about changing resource locations. So if I have different resources that are in different regions, are they all going to show up in one place, or can I configure them all in the same Terraform file?
You can configure them in the same Terraform. You can actually use providers that point to different regions. But in terms of Azure, what you're going to want to do, there are certain things where you would need to change a service plan. So service plans will stick to a specific region. So you might need to create a new service plan. There are certain resources that you might be able to move depending on what that service is, or you might need to recreate those services or that infrastructure in the other region after you've made those changes. So there's a bit of documentation around that, and if whoever has asked that, if they'd like to follow up with me, just please reach out to me on Twitter, and actually anyone on this webinar, if y'all would like to reach out to me and ask any further questions, I'm happy to dive deeper into that as well.
Yeah, it's absolutely possible. You've got, as you were mentioning, the capability in Terraform to do all of that. You can add multiple Azure RM providers to a single Terraform configuration, and you can use aliases. If you want to put things into different resource groups, then you've got that flexibility too, because most of the resources inside will take a link to a resource group. And again, you can define multiple resource groups. So it's incredibly flexible to design just the way the work that you work as an organization.
Thank you both. Nick, we had a question about workspaces. Can you share environment variables across workspaces? So in the demo, for instance, you were configuring your ARM variables. Can those be shared across workspaces?
No, not. I don't even know if that's a roadmap feature. So we try to keep workspaces because you can assign different permissions. So for example, a team, I can be a developer in the developers team, and I can have different permissions per workspace. So we don't allow sharing of variables. You do have to configure those every time, I'm afraid, but it's a good thing in the long run.
Understood. So we did have a question also about configuring Windows patch schedules using Terraform. Is that possible?
That is a very good question. So it depends on the resource. So anything that's available as a resource inside of Azure RM, it'll be configurable from Terraform. There's a couple of resources which are not yet available, but actually what you can also do is you can still use ARM templates. So if you're using ARM templates already, you can actually get Terraform to execute your ARM templates. So as we're busy getting 100% compatibility with the Azure RM, and it's going pretty good. Tom got even more resources out in the release of the Azure provider today. You can always use ARM templates for if there are any missing gaps. But I couldn't say off the top of my head. Have a look in the documentation. It's a good place to check it out. And if not, then ARM templates is an option with Terraform, obviously.
Excellent. Thank you, Nick. Zach, this may be a question for you. We had a question asking about mapping tenant teams to tenants in Azure. Can this be done in Terraform?
Tenant teams to tenants in Azure. I'm honestly not sure of the answer of that. I'll actually have to follow up after that webinar, after this webinar for that question, just to make sure I understand it fully.
Understood. Okay. And then was it one of the other questions that we had just came across adopting like a hybrid cloud infrastructure? Could we talk a little bit about how Terraform is able to configure infrastructure, let's say, that was initially done in a separate cloud, but is now being moved into Azure?
So you do have the capability to import resources with Terraform. So for example, let's say you're using Azure Stack and you're using Azure, so two different sort of clouds. If you've already got an existing setup, then you can use Terraform import. Now, what Terraform import will do is it'll only import the state. You've still got to build out your Terraform configuration, but it'll get you some of the way there. Now, the benefit of using Terraform is that when you are on a migration path like that, you can use the single Terraform configuration to be able to provision into both environments. So you get not only do you get the consistent workflow, but you get that migratory path. So for example, you're bursting into Azure, then you've got the capability to sort of manage your infrastructure in Azure, to scale things up. If you want to modify your infrastructure in your traditional cloud, your on-prem cloud, again, you can use Terraform for that. There's no magic trick where you can kind of just point Terraform at an existing cloud setup and say, give me Terraform configuration files for that. And the reason that it doesn't do that is because the intention behind HCL is to be declarative. So it's very difficult for a machine to kind of write that configuration and get it absolutely right. But there's a number of different sort of solutions to sort of doing that, and maybe we can send out a couple of links. But Terraform import's definitely one thing to check out, and there's a couple of tools out there on the internet as well to get you most of the way there.
Thank you. And So thank you, Nick. Thank you, Zach. We had some great questions. If there's additional information you're looking for, there's the Getting Started resources that Nick and Zach pointed to. I hope everyone enjoyed today's webinar and have a better understanding of how you can run Private Terraform Enterprise on Azure and working together across teams and workspaces. I wanted to thank you all for joining, and a big thank you to Nick and Zach for their time today. I also wanted to mention that HashiCorp is hiring. So if you like what you heard today, please take a look at our jobs page at hashicorp.com/jobs and see if there might be a fit for you. And finally, as I mentioned at the beginning, this webinar was recorded, and we will be making the recording available on our website after post-processing. You'll receive an email from me to everyone who registered with the recording link, and you can also keep your eyes out on Twitter, where the recording link will be made available as well. Hope everyone has a great day. Goodbye.
Laters.
Bye.